Hello and welcome to another fun-filled day in math with Mr. Sims. Today we're going to be talking about special right triangles. And when we talk about special right triangles, we're really talking about two specific types of triangles. We're talking about the 30, 60, 90 triangle, called that because there's a 30 degrees, a 60 degrees, and a 90 degrees, right? And we're also talking about the 45, 45, 90 triangle, which is 45 degree, once again, 45 degree and 90 degrees. That's why it's called that, right? So anyway, those are the two different types of triangles that we will be talking about. They're special triangles. As you can see, this one would be an isosceles triangle, right? Because these are both 45, and so if both angles are the same, then the side across from them would also be the same in a triangle, right? So therefore, you know that this and this length are the same, right? So anyway, in these special right triangles, what's cool is if you actually work it out with the Pythagorean theorem, you can actually figure out essentially the relationship between all of these different sides. And without showing you that right off the bat, I might do that in another video, but just to get into the actual meat of it, what we're going to do is we're going to see that the relationship for a 30, 60, 90 triangle is the side that's across from the 30 degrees is your x value, right? And so whatever x is, the hypotenuse is always going to be twice that, 2x. And this side here is going to be whatever that x is times the square root of 3. All right, so that's the relationship for this one, this particular 30, 60, 90 triangle, or just for any 30, 60, 90 triangle. So it doesn't matter how ugly this x value is. It could be like 3 square roots of 2, 2 square roots of 3 times x squared times negative 4 over 5 billion L law natural. It doesn't matter. Whatever it is, you would multiply whatever that is times 3 to get this side, and then you would double it to get this side, okay? So that's how that relationship works. It helps us out a lot when we're solving these problems. Now, likewise on this one here, if you knew that this was like, let's say, the square root of 3 over 2, right? Then you're going to take that and multiply it by the square root of 2 to get this side here, okay? So anyway, it just helps you out when you're trying to solve these, to have those relationships in mind. You would want to memorize this, okay? So here's what I'm going to do. Here we go. So you have this case, we're going to do some problems just so I can show you how it's done, okay? So here we have a correct answer, right? I'm not going to tell you what the correct answer is. It's there in case we want to see it later. But basically what you have is you have a 30, 60, 90 triangle. This is 90, this is 60, so therefore this must be 30, okay? And that's actually just a little bit too big. Let me make that a little bit smaller. 30, there we go, 30. So that's a 30 degree, right? So if you remember the relationship, right, for a 30, 60, 90 triangle, I'm going to come back here so you can see it again, right? X, 2x, and x square roots of 3, right? So don't get confused with the letters being different. They use their own letters here, right? But you just got to remember that this here is essentially the x, right? That this right here is going to be that 2x, right? And that this one here is going to be x square roots of 3, right? Right? So since that's the case, right? If this is supposed to be x square roots of 3, right? I set my 4 square roots of 3 is equal to x square roots of 3. And I actually could see that that basically x was going to be 4. But I'm just going to go ahead and, right, just for kicks and grins, we're going to go ahead and solve it algebraically, right? Square root of 3, square root of 3. So you get that x equals 4. All right, so now that x equals 4, that's actually not, I gotta be careful because they labeled their letters differently here, okay? So normally I would say x is equal to 4, but in this case it's actually going to be y equals 4, okay? So don't get confused with that. So this one here is going to be 4. This is 4 square roots of 3, and we know that this is 2 times whatever this value is, so that's going to be 8. So y is equal to 4, and x equals 8, right? All right, so that should hopefully make sense to you. Once again, it got a little confusing because I was using x because I think of it as x over here, but really I think I'll change that for the next one and use whatever variable they have there, okay? So in this case, that variable is y, right? Once again, we have a 30, 60, 90 triangle. We know that because 90 plus 60 is, well, 150, so we need another 30 to make the interior angles all equal to 180, right? So we have a 30, 60, 90 triangle. We have y here. So whatever this y is, remember, this x really is y square roots of 3, right? And this 10 here is equal to, right? In this case, this 10 is going to be equal to 2 times whatever this y value is, right? And we know that because of this. This is twice whatever this is, right? So this 10 is equal to twice whatever the y is. So that's just by simple algebra, right? I get that y is equal to 5. All right, so y is equal to 5. That's part of my answer, right? But they want to know x as well. So x, then I'm just going to plug in the y, right? And so x is going to be, x is going to be 5 square roots of 3 is equal to my x, okay? And let's double check to make sure we got that right. The answer is yes. Always it feels good to get things right. It really does. All right, let's go ahead and move on to the next one. Ding, ding, ding. All right, now we're moving on to 45-degree triangles. Yeah. So 45-degree triangles, what we're going to do is we got to remember the relationship. Remember that these two here are the same because it's an isosceles triangle, right? This is a 45-degree. So this one and this one would have to be the same, right? They're congruent. And so y then is going to be equal to 6. Now we also know that this value here, how do we get that value? Well, according to our theorem, right, we get that value by multiplying whatever our length is by the square root of 2. So I'm going to go back here. Oh, cancel. Erase. So what do we got? I forget. Oh yeah, so y is equal to 6. So x is equal to what? Why did that get so big? 12. All right, so x is equal to y times this, whatever this value is times the square root of 2, right? So in this case, x is equal. What? I don't want my eraser. I want my pen. X is equal to y square roots of 2. And as we know, y is equal to 6. So 6 square roots of 2. So x is equal to 6 square roots of 2. My answer should be... Okay, yeah. This is the answer they selected, which is not the right answer. Do not look at this one. This one's wrong. Okay? So the correct answer is this one here. 6 square roots of 2 and 6. Okay? Yep. Looking pretty good so far, right? Feels good to get problems right. Let's go ahead and keep going. Whee! All right, so we got this one here. We have 45, 45, right? So this is once again a 45, 45, right? And we know that this is 3. Now this one we're having to work backwards a little bit, right? So we know that this value here, right, is equal to x, or in this case m, I'm sorry, cancel. Let's do m, right? Is equal to m times the square root of 2, right? And really, I could have used n as well because n and m are congruent, right? So in this case here, what would I have to do? So I have to divide by the square root of 2, right? And divide by the square root of 2. So now I get that m is equal to 3 square roots of 2. Now, if you were looking at your answer choices, that would not be one of the answer choices. And you might freak out. And you have to remember that we need to rationalize the denominator. We do not like to keep radicals in the denominator by convention. And so, we're going to multiply both the top and the bottom by the square root of 2 over the square root of 2, which is really just 1, right? That's one whole. And I'm going to multiply that across. And so when I get that, I get 3 over, oh, sorry, 3 square roots of 2 on top. And on the bottom, I get 2. So 3 square roots of 2 over 2 is equal to m. And if that is the case, that, what is that? If that is the, why? If that is the case, that 3 square roots of 2 over 2, right, is equal to, sorry, that's just bothering me, I gotta fix it. If that's the case, then because it's an isosceles triangle, right, if m is equal to 3 square roots of 2 over 2, then n must also equal 3 square roots of 2 over 2. So we win. Yay! All right. Hopefully that's making sense to you. All right. Now we're going to move on to slightly harder problems. In these harder problems, we get to cry a little bit. It's great. So in these harder problems, what they have is they actually now they give us like this, and they want us to get all the way over to here, right? So what we have to do is find this piece here so that we can find this piece here. So let's look at our relationships. This is a 45, 45, 90 degree triangle. So if this is 10, then this side here would be 10 square roots of 2. Okay? Actually going to get a new layer. I don't like that. So 10 square roots of 2. All right? Now, that 10 square roots of 2, though, is just the beginning. That's this line right here, right? But I don't want this line right here. I want this X line here. So now I have to think back to my relationships for a 30, 60, 90 triangle, right? And the relationship on the 30, 60, 90 triangle is that this one here is whatever this value is times the square root of 3. So X then is going to be equal to 10 square roots of 2 times the square root of 3, right? Because that's what it says, right? Right here. Okay, so I don't want that to stay there. It bothers me like that. Okay, here we go. So in that case, I have X is equal to 10 times the square root of 6, right? And really, I can't simplify that anymore. So 10 square roots of 6 should be the answer. And we're right. Woo-hoo-hoo! Feels good. All right, moving on. Whoa, that was not what I wanted to do. All right, let's go to this one. So this one here, let's see what we have to do. Okay. So we're starting off with 8, right? Now, they want us to find this length here. But in order to find that length there, I first of all have to take and figure out this length. So to get that length, I know that the relationship between this side here and this side here is that this is whatever this is times the square root of 2, right? So this, I'm going to call this, let's call it F. Why not? Let's just, no, you know what? Let's call it P, right? So I'm going to say that P is equal to 8 square roots 2, right? Because of this theorem right here, okay? All right, so P is equal to 8 square roots of 2, right? So now what do I do with the 8 square roots of 2? Well, I know that 8 square roots of 2 was equal to this side here, but they want to know this side here. So really, right, P then, 8 square roots of 2, right? I have to set 8 square roots of 2 equal to whatever this P should be in terms of X. So that's going to be X square roots of 3, right? Because X square roots of 3 is this length here, which is also my P length. Does that make sense? So, and we get that from this formula right here. So what I'm going to do is I set those two equal to one another. Now I'm going to solve for X. So in order to solve for X, I take the square root of 3, I divide by the square root of 3, right? And I get that X is equal to 8 square roots of 2 over the square root of 3. Now, as you know, you're not going to find that answer, right? That answer doesn't look like it. Why doesn't the answer look like it? Well, because you need to now take and multiply this by the square root of 3 over the square root of 3, which is equal to 1, right? In order to rationalize the denominator, get that radical out of the denominator, right? Because they don't like to have those in for final answers. So you now have 8 square roots of 2 times the square root of 3 over square root of 3 times the square root of 3 is just 3. So now I have 8 square roots of 6 over 3. Okay. And that is my final answer. All right, let's just do a quick recap, and then I'm going to let you go. So as you know, we talked about special right triangles. We talked specifically about 30, 60, 90 triangle and the relationships that they have with their different side lengths, right? Whatever this value is here, this is always going to be twice that value, and this side here is always going to be that value times the square root of 3. 44, 5, 45, 90, you have x and you have x, right? Those two values are going to be the same because it's an isosceles triangle. And this value is always going to be x square roots of 2. And then we talked about how to actually solve some problems with 30, 60, 90 triangles, right? And we talked about how to solve some problems with the 45, 45 triangles, right? Remembering that both those sides are the same, right? And then we put it together to solve these multi-step problems, which are kind of fun. Actually, I like these. They're kind of like puzzles. All right, well, I hope that helped a little bit. I wish you the very best of luck in your endeavors on this assignment, and I'll talk to you soon.